This is an introduction to solubility. So just kind of a refresher about solubility, we should know what the word solutions means. Solutions are homogeneous mixtures that are uniform throughout. We learned that in first semester. And a solution is made up of two parts, a solvent and a solute. Remember, the solute is the substance that does the dissolving. For example, water. It's usually the one that's more abundant. It's the one that's the bigger. And then the solute is a substance that you're actually putting into the solvent. So for example, sodium chloride. You're adding sodium chloride into water. Sodium chloride is a solute, water is the solvent. Okay. Today we're going to look at two scenarios. And that is, what if I want to dissolve sugar in water? We've done that before. Versus dissolving salt in water. And maybe you've done that before too. The difference between sugar and salt is that sugar is a molecular compound. So let's remember, a molecular compound is a compound that's between nonmetals. So maybe you remember such sugars from biology like C6H12O6, that's glucose. Carbon, hydrogen, and oxygen, those are all nonmetals. So molecular compounds are ones that have all nonmetals. As opposed to salts, remember salts is just another way of saying ionic compounds. All ionic compounds are salts. So what's an ionic compound? It's a metal bonding with a nonmetal. Or for us, more importantly, it's a cation bonding to an anion. So if you look here in this example, I have sodium, which is a positive, bonding to negative chlorine. You make a neutral compound, sodium chloride. And those can be pulled apart back into their ions. Okay. On this side, if you notice, I have a sugar molecule, and in the sugar molecule, I don't necessarily have the positive and negative sides that you see in a salt compound. Instead, I have an overall carbon-hydrogen chain, and then on the edge of the chain here, I've got a slightly, remember that's the slightly positive, slightly negative charge, oxygen bonded to hydrogen. That is not a full-out positive-negative, that's just slightly. Right, we got, ooh, I should change that around. We've got oxygen as the slightly negative, let's fix that, and hydrogen is the slightly positive. Oxygen hogs more of the electrons in this covalent bond. Okay, so how do they dissolve? Well, they actually dissolve in very different ways. Okay, salt can be ripped apart, right? Any salt into its ions, but a sugar molecule does not get ripped apart. So let's remember that. So first we'll start with our next term, which is known as solvation, also called dissolution. And what solvation is basically when the solvent surrounds the solute and rips it apart, okay? Or tears it to the point, or pulls it out for the point where it starts to dissolve. So there's ionic solvation and molecular solvation. In other words, there's ways that ionic compounds dissolve, and there's ways that molecular compounds dissolve. That's all that means, and we're going to go through examples of that so you can understand. So we're going to first start off with, let's take a look at salt. Okay, so in my beaker I just have some salt, and notice I have my positive and negatives all bonded together. So, you know, sodium chloride bonded all over together. Remember, one little crystal of salt has thousands and thousands and millions of sodiums bonding to chlorine, sodium bonding to chlorine, sodium bonding to chlorine. And they're all connected together. So you have constant positive, negative, positive, negative, positive, negative. Well, now I'm going to throw that salt into water, and what happens? Well, as you see, my salt got kind of eaten away, it appears to be. And what's really happening is the water is attacking the salt. And the water itself, right, here's my water molecule, has very strong covalent bonds. So the water doesn't break apart. But instead, the water is able to break apart these ionic bonds. And so what they do is they go and they surround different parts of the salt. Notice, very important, the positive ends of the water, positive ends, the blue hydrogens, surround the negative parts of the salt. And the negative ends of the water, the oxygen, surround the positive parts of the salt. This process is called solvation. So the salt slowly gets ripped up into its ions. Now, molecular compounds do not go through solvation in the same way. Okay? Molecular compounds instead, let's take a look at them. Molecular solvation has molecular compounds. So let's look at this. This is a molecular compound. Carbon bond to carbon. I've got some green hydrogens, oxygen, right, and hydrogen. So this is a molecular compound right here. Here's another one. Here's a third one. Here's a fourth one. So we'll pretend like this is a clump of sugar in here, right? You throw in a clump of sugar, or even one little grain of sugar has millions of these. And so instead of coming apart, right, this entire compound stays intact. And so here's what happens when you dissolve your sugar in water. So here comes the water, right? The water instead sees this positive tail, and the negative end of water connects to it and pulls the entire molecule from the bunch. Okay, then the same thing over here, negative and positive links up, negative and positive link up, and so forth. And so that clump of sugar now dissolves into the water. This process where the solvent pulls apart things, right, takes that clump that you see sitting at the bottom of your cup or beaker and makes it dissolve, is called solvation. Okay, so now that we know that, what you've been looking at are these, let's see here. In ionic solvation, the first example, polar molecules, which is water, surrounds ionic compounds. And water rips the ionic compound into its ions. That was this. Oops, no, not that. That was that other picture, which I don't know where I put back, but you saw it. Okay, in molecular solvation, which you just saw, it involves molecules, not ionic compounds. And the clump of sugar, for example, has many sugars in it, and water pulls each sugar molecule apart from the clump, not from each other. So it literally just takes it from the clump, like you just saw me do in this example. Okay? All right. So the next important thing is, if you notice, I kept using water. Water is the universal solvent. It's used a lot. And if you remember, water is polar. That's important. Well, we have some really great rules that can help us decide whether things are going to dissolve. Polar molecules will dissolve in polar molecules. So in the case of my two examples, if sugar dissolves, then it's polar. And if water is the other part, then it's polar. Polar and polar put together dissolves. Nonpolar and nonpolar dissolve. So if I have two nonpolar things come together, they can dissolve. So we call this like dissolves like. This polar and polar are alike, nonpolar, nonpolar alike. So will nonpolar and polar dissolve? No. And if you think about it, polar is water, nonpolar is oil. Excuse me. Do those dissolve? No. Okay, so that's a good general rule to memorize. Lastly, in this video, we're going to learn about a few vocabulary words which are important when pertaining to solutions. You can have three different types of solutions. You can have a saturated, an unsaturated, and in a second we'll get to a supersaturated solution. A saturated solution, well, if you think of the word saturated, it means that it's full of something. And that's exactly what saturated means in this instance. It's a solution that is full of solute, meaning it can't dissolve anymore because it's reached its maximum capacity. There's so much dissolved. So if we look here, let's pretend we have a test tube full of water and some salt. We dissolve, we dissolve, we dissolve, we dissolve, and we hit the maximum capacity. What's our proof that we've hit the maximum capacity? If you're doing this in lab, you would see some solute left over on the bottom because the water's saying, hold on, I can't dissolve anymore. I dissolved so much. So here's the proof that I've dissolved the max. So in a saturated solution, you're going to need to look for that solute left over on the bottom. If you don't see it, you need to keep dissolving. In an unsaturated solution, just like you hear unsaturated, meaning it has not reached its maximum capacity. It's under capacity. So it's a solution that dissolved less than its maximum capacity. So if you look at the test tube, it appears like this. All of the solute is dissolved, but we don't know if we hit our max, because if we hit our max, then we would see a little bit hanging out. So there is solute in here, but we haven't hit our max. Remember, every water molecule will pull apart and hold on to that solute part. So if there's no more water molecules to do that, then the solute falls to the bottom. Well, this clearly hasn't reached out its max. Okay? Another good rule to know in general with solutions is if you want more solute to dissolve, you can actually raise the temperature and more will dissolve. So solutes and its dissolving capacities depends on temperature. Higher the temperature, more can dissolve. Okay? So how about a supersaturated solution? Well, a supersaturation can hold more than the maximum amount of solute at a given temperature. But here's the thing, in order to do that, you have to heat it up, dissolve more in there, and then cool it back down to room temperature. And this is what it looks like. Kind of tricky, because a supersaturated and an unsaturated look the same. The only difference is we've driven this beyond its point. So in a sense, it's very unstable, right? All of that solute is sitting in there, right? And any little disturbance is going to cause it to spill out. And so if you look at this, here's kind of the pictures. Here's my supersaturated, right? Let's remember, this is holding more than it should. And the reason why we did that is we forced it at a higher temperature, we dissolved more. Then we slowly cooled it down to room temperature. It's still holding on to it, right? But it's kind of nervous, saying at any moment, all that extra solute can fall out. And literally, if a little piece of dust falls on this, or in this instance, we say if one seed crystal, one little crystal, you just add it, the whole thing, all the solute spills out of the solvent, and it all crystallizes out. We're going to see this in class. That's a supersaturated solution. Last two things that you should know are a dilute solution versus a concentrated solution. That's the way I abbreviate solution. A dilute solution means that there's more solvent, right? A lot more water than solute. You can add a lot more water to dilute down a solution. A concentrated solution means that there's a lot more solute in your solution compared to your solvent. It's very concentrated. That's the end of the video.